Welcome to part 2 of the video series on network diagrams and the critical path. In this video, we'll be covering critical path analysis, and we'll look at the forward pass, early start and early finish, and the backward pass, late start and late finish. Completing the forward and backward pass helps to answer some questions. The forward pass helps us to know how soon can an activity start, and how soon can an activity finish. And also, how soon can the project as a whole finish? The backward pass helps us to know how late an activity can start and how late it can finish, as well as what activities represent the critical path. And lastly, how long can each activity be delayed? So let's have a look at how to do this. First of all, we sequence the activities. So here we have 3 columns. The first column gives the activity and identifier A, B, C, D, E, F, G, and H. There's then a brief description of each activity, and in the last column it tells us what the preceding activities are. So it's telling us that activity A has no preceding activity. Technically it could start on day 1. Activity B, C, and D are related to activity A, and activity A are their predecessor. So let's have a look at what this sequence actually looks like. And here it is here. So we saw activity A, and we noted that B, C, and D are all dependent on activity A, or activity A is a predecessor to B, C, and D. Going back, we can see that E is dependent on B and C, and F is dependent on B, C, and D, as these are the preceding activities. Let's have a look at those. So here's E, and it's dependent on B, there's the arrow, and it's also dependent on C, there's the arrow going up from C to E. Down here, F is dependent on B, there's one arrow, C, and D. So B, C, and D are all predecessor activities for F. Let's go back up. G is dependent on F, and H, which is final occupancy, is dependent on E and G, as those are the preceding activities. So here's G being dependent on F, and here's H, final occupancy, dependent on E, there's the arrow, and G as well. So now we've sequenced the activities. Next, we want to add some durations. So there's a legend or key down the bottom here indicating what the different things on this network diagram mean. And we're concerned with duration at the moment, which is shown down the bottom. So through good estimation methods, we've determined the different durations or time required for each of the different activities. So this will be 5 days, 15 days, 10 days, 5 days, 10 days, 15 days, over here 170 days, while construction is completed, and finally 35 days for occupancy. Now we're ready to carry out the forward pass, and this is going to tell us our early start and early finish. On our legend, these are shown at the top here, either side of the identification. So first we have activity A. It's telling us that the early start day is 0. It's going to take 5 days. So 0 plus 5 is 5, which means that the earliest we could finish this is on number 5, day 5. Now B, C, and D are all related to A. A is a predecessor to those 3, so we need to take 5 all the way through to these 3 activities. So it's telling us the earliest day we can start these activities is on day 5, because A has to be completed. Up the top, 5 plus 15 is 20 for B, 5 plus 10 is 15 for C, and 5 plus 5 is 10 for D. So it's giving us these different time frames for our earliest finish days on these activities. Now, as we go forward, we need to take across the largest number. So if we have a look here at E, there's a choice between 20 or 15. And for F, we have a choice of 20, 15, or 10. We have to take the largest number because everything has not been completed yet in terms of taking across a smaller number. So if we take across 20, we can be sure that all these different activities have been done. And here it is, 20. So on E, 20 plus 15 is 35, and on F, 20 plus 10 is 30. For G, we're going to take that 30 across here, add it to 170, and that's going to give us 200 days for this piece of work. Here we have to take across the largest number. If we don't, not all of the required work will be completed. So 200 plus 35 equals 235, and this is indicating that 235 days is the fastest time frame that we can get this project done in. That's our project time frame. Now let's look at the backward pass. In our legend, these are shown down the bottom next to the duration. In the backward pass, we're working backwards through the network diagram. So previously we've established that 235 days is the quickest we can get the project done in, and that's actually our project time frame. So it's also the last day or the latest finished date that we want in our project. So we take 35 away, and that's going to leave us 200. We're going to take this 200 backwards, and it will appear in both E and G here. Working with E, 200 minus 15 gives us 185, and for G, 200 minus 170 gives us 30. Here we're going to take that 30 backwards, minus 10 equals 20. Now we have a choice here of which ones to take backwards, and we always take backwards the lowest number. So although we have 185 here, 20 here, which goes to all three, is the one we're going to take back. So 20 minus 15 is 5 for B, 20 minus 10 is 10 for C, and 20 minus 5 is 15 for D. Once again, we take back the lowest number. In this instance, it's going to be 5. 5 take 5 is 0. So we've now done the backward pass. Having done this, it becomes easier to calculate the slack or float. Let's have a look at that. So the slack or float on our legend or our key is at the side here. And if we look here, our slack or float on A is 0. That means we have no time up our sleeves. We have to start it immediately, and we have to do our 5 days and finish it. So you can see here all of these numbers are the same. So what we come to realize is that the critical path has 0 slack or float. So anything that has a 0 is going to indicate to you that it's on the critical path. Let's investigate further. So construction plans also has 0, that must be on the critical path. Next, the commission approval has 0, it's on the critical path. It leads to waiting for that construction. No slack or float again, no time up our sleeve, it's on the critical path. And lastly, so is occupancy. So through doing this process, A, B, F, G, and H can be seen as our critical path. Now what this means is a slack or float is the time you have up your sleeve on each task or activity to complete it and still keep the project on track. So this is telling us that we have quite a little bit of decision making and quite a few options as to when we start this staff report. As long as we start it before day 185, we're safe and we won't impact the total time frame. The same here, we have a slack or a float of 5 days up our sleeves, so we can decide when in those 5 days we start the traffic study, as long as we start it no later than day 10. If we're after day 10, let's say day 11, that's going to push everything out. Okay? And then down here, again, we have some slack or float of 10 for the service desk. The latest day we can start this without affecting the timeline is day 15. If any of these things with 0 float go over time, our whole project is going to go over time. So imagine if we get to commission approval, it takes an extra 5 days. That's going to push the whole project out by 5 days. So now for an activity. this will be over to you. So based on the following information in the table, draw a project network diagram using the activity on node technique, identify the paths and the duration of each path, identify the critical path, and determine the early start, early finish, and late start, late finish for each activity. So let's get you started. First, you'll want to use a grid. So just like in the previous example, we'll use a 9-square grid. The first activity is A, and it has no predecessor, and the duration is 10. B has A as a predecessor, so again I'm going to make a 9 grid box, and I'm going to put B at the top, and over here the duration is 10. We then have C. It's also connected to A. I put in my 9 box grid with C, and C has a duration of 20. So I've got you started. Work through those 4 activities and then I'll show you the answer. So let's work through the answer to this activity. Our first point is to draw a project network diagram using the activity on node technique. So first, following our table, we have activity A. And it goes for a duration of 10. From there, activity B has a predecessor A, also a duration of 10. C also has a predecessor of A, and the duration is 20. And then D also has a predecessor of A and a duration of 12. E has a predecessor of B and a duration of 10. So coming from B, we go to E. F has a predecessor of C and a duration of 25. And G has a predecessor of D and a duration of 8. We then have H, which has predecessors of E, F, and G. So we actually call this a merge. All of these activities are merging into H. And it has a duration of 10. So now we've ticked off the first part of the activity, drawing our network diagram activity on node. Now we need to identify the paths and the duration of each path. So our first path is across the top, and it's A, B, E, and H. And all I'm doing is just following these arrows. Okay, A to B, B to E, E to H. The next path is A, C, F, and H. And the last one, A, D, G, and H. We now need to figure out the durations and just some simple addition. So A, B, E, H, that looks like 10 times 4 is 40. Across the middle, A is 10, plus C makes 30, plus F makes 55, and H is plus 10, making that 65. And down the bottom, A, D, G, H, A at 10 plus 12 is 22, plus 8 is 30, plus 10 is 40 for the last path as well. So now we can tick off the second activity point. Lastly, here we identify the critical path. So that's easy, it's the longest path or the largest number. So ACFH at 65 is going to be the critical path. Now we'll determine the early start, early finish, and late start, late finish. I'm going to start with early start, early finish. So A can start at the very beginning, and it needs to start at the beginning. It's the first activity. 0 plus 10 is 10, and we take 10 forward as the earliest day we can start on all of those activities. So all of the activities that have A as a predecessor all have 10 taken forward. Now B, 10 plus 10 equals 20, C, 10 plus 20 is 30, and D, 10 plus 12 is 22. Moving to E, we're going to take 20 across there. F, we're taking across 30. And here 22 for G. 20 plus 10 is 30. 30 plus 25 is 55. 22 plus 8 is 30. Now in this merge activity, we need to take the largest number across, and it's 55. If we took across 30, some of A, C, or F may not be complete. So we need to make sure we take the largest number across. 55 plus 10 equals 65, which agrees here with our critical path and the time frame that this project is going to take. So we've now completed the forward pass. It's time for the backwards pass. So the backwards pass is identical here. 65 take 10 is 55. So because this is on the critical path, it has 0 slack. So 55 take 55 is 0, and we know it's on the critical path. And we take 55 back for each activity. So 55 goes backwards. So 55 take 10 is 45. 55 take 25 is 30. And 55 take 8 is 47. We can see here in the middle that 30 take 30 is 0. So we know this is on the critical path. However, here 20 from 45 is 25. This means we have a slack or a float of 25 on task E. And down the bottom, 22 from 47, it also equals 25. So we have slack or float there of 25 on G. So working backwards across the top, again here we're going to take 45 backwards. Here we take 30, and for D we take 47. Up on B, 10 from 45 leaves 35. 30 take 20 equals 10. And 47 take 12 equals 35. And again we can calculate the slack or float. So 35 take 10 here also equals 25. So our slack or our float on B is 25, is 0 here on C. We know that's on the critical path. And 35 take 10 again here is 25. And we want to take back the smallest number to A, which is 10. And 10 minus 10 is 0. So again, we have 0 slack here or float, which means that is also on the critical path. So what this is now telling us, for example, with B, is that we have 25 days or weeks, whatever that duration is done in, to play with in order to get activity B done. So as long as we start no later than on day 35, we can organize where we and how we schedule activity B. And the same for activity D down the bottom. We have 25 days or weeks of time up our sleeve, and we can organize our scheduling as we see fit. We might not want to start those activities all on that same day. On day 10, we could spread our resources about and make some decisions. So we've identified the critical path and we've determined the early start and finish and the late start and finish, and so we've completed that last activity. On a final note, we'll look at network diagrams and their relationship to Gantt charts and how it appears when using software such as Microsoft Project. At the top we have the network diagram, so order review leading to order vendor parts, produce other standard parts, design some custom parts, software development, designing of custom parts goes into manufacturing some custom hardware, which goes into assembly and then down to testing. So we've got a few different paths through this network diagram. So as we saw before, this network diagram is showing the start and the finish dates, and it's given an ID number and a duration of 2 days. RES means resources, so we could have put resources in here like a team or a person's name or some equipment, whatever resources we thought might be required. Now, when you look at the Gantt chart down the bottom, which is a schedule that shows this bar chart demonstrating relationships between the different tasks, we can see here it gives us some information. So it gives us the ID number of the task or activity. It gives us the duration. So here it's 2 days. The task name, we can see order review, order review. It gives us a start day and the finish day. So that's there, start and finish. But it also shows us the late start and late finish. We can see the slack here, so we know this must be on the critical path. There's 0 slack, and anything with a 0 we know is on the critical path. When you look at the bar chart over here on the Gantt chart, it also shows you how different activities are related together. So it's showing us that after order review is done, there are a number of different activities that all start or can start at the same time. And then, as we can see here, this ID number 4, the custom parts, it actually leads to ID number 6, which then goes to assemble. And we can see that little arrow here going from number 4 all the way down to number 6 and then following through. These relationships seem to indicate that when one task finishes, the next task can start, although these 4 are scheduled concurrently to all start at the same time. They may in fact have a start-to-start relationship. So in software in particular, you can schedule in so that different activities have certain relationships. Some things may need to start together or finish together and so forth. In part 3, we'll look at the different types of relationships in a network diagram in more detail. We'll look at opportunities to decrease the critical path and therefore the length of the project. And we'll also look at some tips for estimating how long activities should go for, the activity durations.